This video provides a summary of the procedure detailed in AASHTO T85, specific gravity and absorption of coarse aggregate. Aggregate specific gravity is necessary to determine weight to volume relationships. Aggregate absorption affects the amount of water which will be unavailable to react with cement and Portland cement concrete and provides an indication of the amount of asphalt binder which will be absorbed into aggregate particles in asphalt concrete. When performing coarse aggregate specific gravity tests, the following safety precautions are required: safety glasses, thermal insulated gloves, long sleeves, long pants, and closed-toed shoes. The following equipment, materials, and supplies are required to conduct coarse aggregate specific gravity tests: a pan, a scale, a wire basket apparatus, a water bath, a towel, an oven, and a coarse aggregate sample. The mass of a coarse aggregate sample is determined in the saturated surface dry, abbreviated SSD, oven dry, and submerged states. These values are then used to calculate bulk specific gravity, SSD specific gravity, apparent specific gravity, and absorption. The following provides a summary of the steps required to determine coarse aggregate specific gravity and absorption. Place a pan on the scale and tare the scale. Take the pre-selected dry coarse aggregate sample and place it into the pan. Record the mass. This is the initial dry sample mass, which should be approximately 2,000 grams. Remove the pan from the scale and tare the scale with the wire basket attached. Place the aggregate in the basket and submerge it. Attach the basket to the scale. Wait 3 minutes to allow water to fill the aggregate pores. The difference between the submerged mass and the dry mass is equal to the weight of water displaced by aggregate. The displaced water has a volume equal to the volume of the aggregates. Since the density of water is known, the mass of the displaced water can be used to determine the volume of aggregate. After 3 minutes, record the submerged mass. For this example, the submerged aggregate mass is 1,244 grams. Disconnect the basket from the scale. Pour the aggregate onto a dry towel, ensuring all particles are transferred from the basket to the towel. Roll the aggregate particles around on the towel until their surface is no longer shiny, but the particles are still wet. This represents the condition where the aggregate pores are filled with water, but the surface of the particles are dry. This is termed the saturated surface dry condition. Place an empty pan on the scale. Tare the scale. Place the saturated surface dry aggregate sample into the pan. Record the mass of the sample. For this example, the SSD mass is 2,005 grams. Place the pan with coarse aggregate into an oven overnight to dry. After cooling, place the pan with dried aggregate onto a scale. Record the mass. Subtract the pre-recorded pan mass to determine the oven dry aggregate sample mass. In this example, the oven dry mass is 1,990.5 grams. Bulk specific gravity is calculated by dividing the oven dry sample mass by the SSD sample mass minus the submerged sample mass times the density of water. SSD specific gravity is calculated by dividing the SSD sample mass by the SSD sample mass minus the submerged mass times the density of water. Apparent specific gravity is calculated by dividing the oven dry sample mass by the oven dry sample mass minus the submerged sample mass times the density of water. Absorption is calculated as the difference between the SSD sample mass and the oven dry sample mass divided by the oven dry sample mass times 100%. For this example, the bulk dry specific gravity is 2.615, the SSD specific gravity is 2.635, the apparent specific gravity is 2.666, and the absorption is 0.73%.